Hey guys, welcome back to the channel. Today I'll be showing you guys how to scrape this ETF table or this ETF database. And in this tutorial, we'll be able to scrape these ETFs by category. So here in bar chart, we have several categories. So we have a list of ETFs that are classified as equity ETFs, along with commodity ETFs, currency, fixed income, alternative, and also a mixed asset ETF. Now I have these sorted by assets under management, and I have all of these boxes checked. Not only am I able to scrape this table along with these columns, but if we click on this drop down menu, we can also get the technical information, performance, and fundamental. So if we click on technical, we can also scrape these columns that are missing from our main view. So if we take a look at an example of how this table looks like in R, we will be able to get a total of 26 columns and all the ETFs that are listed on bar chart. So we have the ticker or symbol, the symbol name or the ETF name, the last price, the percentage change in a month, 3 months, the average volume in 20 days. Now for trend spotter signal, on bar chart you will see these as sell, which is -1, hold, which is 0, and buy if it's a +1. We also include our column for leverage. This will tell us if the ETF is long or inverse, the assets under management, the symbol code, which are all ETFs, the symbol type. So we added this column to kind of categorize this ETF. So all of these in this list will either be equity, commodity, fixed income, or alternative. The opinion score based off of bar chart. We also get the relative strength in the past 20 days, historical volatility, the 52-week high and the 52-week lows, the weighted alpha, the percentage change year to date, also the percentage change in a year, the daily last price of the ETF. We also include the management fees, the dividend rate, along with the dividend yield. We also get a column to tell us whether this ETF has options or not. And finally, we just added a column that will let us know when we scrape this information. Once we have this table, we can extract all the tickers found in this table, and then we can pass all the symbols into a function that will scrape the description and the category for this ETF. So say if you're looking for an inverse ETF with exposure to Asia, we can look that up. And that information comes from ETF DB. So if we go to their page, under their ticker profile, we will be essentially scraping these two tables, the themes and the classifications. So all the tickers we pass in will get information from this page. And once we have this table, we can easily look up ETFs and their exposures. So let's go take a look at our script. All right, so here are some of the packages we're going to require. Our first function will get all the ETFs from bar charts, and the second function will scrape the category, sector, and detail from ETF DB. And as you noticed, for the first function, we don't need to pass in anything for the parameters. But if we open up this function, they have broken down these ETFs into 6 categories based off of their number. So 1 is for equity ETFs, 324 is for fixed income ETFs. Once we have these numbers, we could just pass these into a URL that will look up that page. And I also assign the types to match up these numbers. We will kind of be doing a VLOOKUP so that we can add the ETF types to the table. Here I'm just going to column bind the numbers and types and save this as a data frame, and converting these categorical numbers into numeric variables. Once we have our lookup table saved, we're going to pass in each of the numbers into this function. We're going to pause the script for 5 seconds so that our IP doesn't get blocked, and then we build the URL. This is the URL to the page that we will be scraping. It'll go ahead and add the number that we pass into the URL, and then we're going to do HTML sessions and assign that to page. Once we have established a connection with that page, I'm going to extract the cookies, and within the cookies we need to extract our token because we will be sending a GET request. This is the URL that has all the information we need to extract. And as you can see, we are passing in our fields for all the columns we need, along with our token we extracted and the page handle. So once we read that in, we can extract the content. I'm going to row bind all the results, and then I'm going to add the symbol type. So it'll look up from our table and assign it one of these types depending on the page. And then finally, just return that table. So again, it'll kind of just loop around these numbers, scrape the information, and return the table. And all these will get saved as a list into data. And once we have data, we can just row bind all of our results so that we just have one big table with all the ETFs and their information. Once we have that, I'm going to add the date so that we know when we scrape this information. And then finally, just return that data frame. So here I'm just going to go ahead and minimize this function. I'm going to go ahead and run it, and then save all of our ETFs into this variable. Once we get all of our ETFs, I recommend you save this somewhere. I like to save my files as RDS files just so that we have this information readily available. This process takes about 40 seconds to run. So if we open up our ETF table, we see that we got all 26 columns and 2,900 different ETFs. All right, so now that we have this table, I'm going to go ahead and extract all the symbols, and we're going to pass these into our next function. And within this function, I'm just going to pass in the URL to take us to the ticker profile at ETFDB. If we run through an example, I have assigned the SPY as our symbol. So I'm going to build a URL. I'm going to read that page in and then pass in the XPath to the location of the table, which will be our first table, which would be this one. Now this table will differ in range. That's why I read the table instead of each and every row, as we will be doing with this FactSet classifications table. And the reason is that sometimes they will add or subtract some of these categories. So again, this range will differ. So that's why I pass in the XPath, and we're going to assign that into table 1. So let's scroll up and take a look at table 1 out in the console. So what I'll be doing next is I'm gonna str split, but first convert this as text, and the split pattern will be new line. So if we run this and take a look at table 1, now we see the information we need. We just need to get rid of these empty spaces, and I do that with str count. So the length must be greater than 0, and again returning that at table 1. So let's take a look at table 1 again. We have essentially turned this into a character vector and got rid of the empty spaces. Now at first try, I try to build a matrix that is 2 by 2, similar to the page. But if we run this and take a look at table 2, and we see that it's a little bit off, since some of the items in column 1 need to be in column 2 and the items in column 2 need to be in column 1. So I kind of grouped them the wrong way. So since table 1 is in the right order, I'm just going to end up grouping by odds and evens just so that the order is consistent. So within our script, I just built a sequence of odds and a sequence of evens, and we're going to reassign our columns in table 2. And then we're just going to reassign table 1 and remove table 2. And then just finally transpose that table. So we take a look at table 1. This is what it looks like right now. And after we transpose it, we're going to switch rows with columns. Since we're going to end up row binding everything, now we need to set this first column as column names. So we're going to do that in the following line, and then drop that first column. So if we take a look at table 1 again, now we have the information grouped as we want. All right, so I'm going to minimize the console and we'll check out how to scrape the second table. For the second table, or the FactSet classifications, we're always going to see the same classifications. I didn't encounter any changes to the number of rows within the table. All we really need is this first XPath, and I'll show you that in our script. So here we have all the rows that we need, and within the XPath, they all stay exactly the same. The only thing that changes is what row this is for. So in the second to last variable, we see TR1, TR2, TR3, all the way down to TR6. By just passing in the XPath, I'm just going to return these as text. And once we have that, for each of these, I'm just going to split each case of new line with an empty space. So I'll go ahead and show you that for the first instance. I'll go ahead and run this line, and then we'll take a look at this variable. So we have effectively returned this segment. Now we just need to get rid of these new line delimiters. So by running the second line, we can get rid of them. And if we run FactSet again, now we get a clean version of the segment. So for each of these cases, it'll be exactly the same. So I'll go ahead and minimize the console again. I'll go ahead and run the rest of the lines. Once we have saved all these variables, we can go ahead and return everything as a data frame. So I'm grouping the symbol, our first table, along with the information we scraped for the second table. So let's go ahead and run that. And if we take a look at the console, so this is what our table will look like, along with categories and classifications that belong to the ETF you pass in. Now let's go ahead and minimize the function and run it. All right, so as I mentioned, we're going to go ahead and grab all the ETFs found in our first table and pass them into our second function. And here as an example, I'll just go ahead and run the first 3. We're going to pause the script for 5 seconds so that our IP address doesn't get blocked. And we're going to try and get all the information from ETFDB. If it does encounter an error, it'll just go ahead and skip them. And it may be that the ETF is no longer trading. It'll go ahead and skip them. Otherwise, it'll return the data. So let's go ahead and run this. Since this gets returned as a list, we need to go ahead and row bind list and convert that as a data frame. And in this instance, we were able to grab all 3 of the tickers we passed in. So we're showing a symbol, category, asset class size, the style, the region, a specific region, the segment, the category, the focus, the niche, the strategy, and their weighting type. If you end up passing in all the symbols, you'll see a much larger table, and that's because our first table that we scrape from ETFDB differs in size. But by using R bind list, it'll go ahead and match up the columns, and it'll kind of sort each of the instances to their proper columns. So this concludes the video, guys. I hope this was useful information. I'll go ahead and leave a link down in the description area where you can find the script. Please subscribe to the channel if you haven't done so already. Thank you so much for watching, and I'll see you guys in the next video.